Many astronomers now believe Planet 9 might not exist at all, and here's why. This is by Samantha Lawyer, The Conversation, and it's on Science Alert. Planet 9 is a theoretically undiscovered giant planet in the mysterious far reaches of our solar system. The presence of Planet 9, or sometimes called Planet 10, or Nibiru, Planet X, has been hypothesized to explain everything from the tilt of the sun's spin axis to the apparent clustering in the orbits of small icy asteroids beyond Neptune. But does Planet 9 actually exist? The Kuiper Belt is a collection of small icy bodies that orbit the Sun beyond Neptune at distances larger than 30 AU. One astronomical unit, or 1 AU, is about the distance between the Sun and the Earth, 92 million miles. These Kuiper Belt objects, or KBOs, range in size from large boulders to 2,000 kilometers or 1,200 miles across. KBOs are leftover small bits of planetary material that were never incorporated into planets, similar to the asteroid belt. The discoveries of most of these successful Kuiper Belt survey to date, the Outer Solar System Origin Survey, or OSSOS, OSSOS, suggest a sneakier explanation for the orbits we see. Many of these KBOs have been discovered to have very elliptical and tilted orbits, like the orbits of Pluto. Mathematical calculations and detailed computer simulations have shown that the orbits we see in the Kuiper Belt can only have been created if Neptune, originally from a few AU closer to the Sun, and migrated outward to its present orbit. Neptune's migration explains the pervasiveness of highly elliptical orbits in the Kuiper Belt and can explain all of the KBO orbits we've observed, except for a handful of KBOs on extreme orbits that always stay at least 10 AU beyond Neptune. Now, is there any proof of Planet 9 or Planet X or Nibiru? These extreme orbits have provided the strongest evidence for Planet 9. The first few that were discovered were all confined to one quadrant of the solar system. Astronomers expect to observe orbits at all different orientations unless there is an outside force confining them. Finding several extreme KBOs on orbits pointed in the same direction was a hint that something was going on. Two separate groups of researchers calculated that only a large, very distant planet could keep all the orbits confined to part of the solar system, and the theory of Planet 9 was then born. Planet 9 is theorized to be 5 to 10 times as massive as our Earth, with an orbit ranging between 300 and 700 AU. There have been several published predictions for this location in the solar system, but none of the search teams have yet discovered it. After more than 4 years of searching, there is still only indirect evidence in favor of Planet 9. Searching for KBOs requires careful planning, precision calculations, and meticulous follow-up. I am part of the OSSOS, a collaboration of 40 astronomers from 8 countries. We use the Canada, France, Hawaii telescope over 5 years to discover and track more than 800 new KBOs, nearly doubling the number of known KBOs with well-measured orbits. The KBOs discovered by OSSOS range in size from a few kilometers to over 60 miles, or 100 kilometers, and range in discovery distance from a few AU to over 100 AU, with the majority at 40 to 42 AU in the main Kuiper Belt. KBOs do not emit their own light. These small icy bodies only reflect light from the Sun. Thus, the biases against detection at larger distances are extreme. If you have a KBO 10 times farther away, it will become 10,000 times fainter. And because of the laws of physics, KBOs on elliptical orbits will spend most of their time at the most distant parts of their orbits. So while it's easy to find KBOs on elliptical orbits when they are close to the Sun and bright, these KBOs spend most time being much fainter and harder to detect. This means that KBOs on elliptical orbits are particularly hard to discover, especially the extreme ones that always stay relatively far from our Sun. Only a few of these have been found to date, and with current telescopes we can only discover them when they are near pericenter, that is, the closest point to the Sun in their orbit. This leads to another observation bias that has historically been ignored by many KBO surveys. KBOs in each part of the solar system can only be discovered at certain times of the year. Ground-based telescopes are additionally limited by seasonal weather, with discoveries less likely to happen during when cloudy, rainy, or windy conditions are more frequent. Discoveries of KBOs are also much less likely near the plane of the Milky Way galaxy, where countless stars make it difficult to find the faint, icy wanderers in telescopic images. What makes OSSOS unique is that we are very public about these biases in discoveries, and because we understand our biases so well, we can use computer simulations to reconstruct the true shape of the Kuiper belt after removing these biases. Adjusting for biases, OSSOS discovered a handful of new extreme KBOs, half of which are outside the confined region and are statistically consistent with a uniform distribution. A new study currently in review corroborates the non-clustered discoveries of OSSOS. A team of astronomers using data from the Dark Energy Survey, or DES, found over 300 new KBOs with no clustering of orbits. So now, two independent surveys, both of which carefully tracked and reported their observational biases in discovering independent sets of extreme KBOs, have found no evidence for clustered orbits. All of the extreme KBOs that have been discovered prior to OSSOS and DES were from surveys that did not fully report their directional biases. So we do not know if all these KBOs were discovered in the same quadrant of the solar system because they were actually confined, or because no surveys searched deep enough in other quadrants. We performed additional simulations that showed that if observations are made only in one season from one telescope, extreme KBOs will naturally only be discovered in one quadrant of the solar system. Further testing the Planet 9 theory, we looked in detail at the orbits of all known extreme KBOs and found that all but the two highest pericenter KBOs can be explained by known physical effects. These two KBOs are outliers, but our previous detailed computer simulations of Kuiper belt, which included gravitational effects from Planet 9, produce a set of extreme KBOs with pericenters smoothly ranging from 40 to over 100 AU. These simulations predict that there should be many KBOs with pericenters as large as two outliers, but also many KBOs with smaller pericenters, which should be much easier to detect. Why don't the orbit discoveries match the predictions? The answer may be that the Planet 9 theory does not hold up to detailed observations. Our observations with a careful survey have discovered KBOs that are not confined by Planet 9, and our simulations show that the Kuiper belt should contain different orbits than we observed if Planet 9 exists. Other theories must be invoked to explain the high pericenter extreme KBOs, but there is no lack of proposed theories in the scientific literature. Many beautiful and surprising objects remain to be discovered in the mysterious outer solar system, but I don't believe that Planet 9 is one of them. Samantha Lawler, assistant professor of astronomy, University of Regina, Saskatchewan, obviously, in Canada. Article published from the Conversation of the Creative Commons, and this is on Science Alert. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece. in Capota, and we also help the young generation with university tuition and the community around our church. Thank you.